Howdy everyone, all good with the topic of alkanes? Terrific! We'll move on right ahead to the alkenes and what they're all about and what the whole thing has to do with rotten bananas. Let's go! Alkanes are, of course, the saturated hydrocarbons. In other words, molecules without multiple bonds. Alkane, saturated hydrocarbons? What? You're just missing the framework to put it all together, right? Don't worry, just take a quick look at the video about alkanes to get up to speed in no time. In the hydrocarbon family, there are saturated forms as well as unsaturated forms. And what do you think their properties are? Exactly, simply the opposite to the saturated ones. Very logical, right? Unsaturated hydrocarbons contain multiple bonds. In other words, they have at least one double bond. And how does that relate to alkenes? Well, alkenes are exactly this type of unsaturated hydrocarbons. They are only made up of carbon and hydrogen, with two of those carbon atoms connected by a double bond. The alkene series therefore always starts with ethene, because we need at least two carbon atoms to form one double bond. After that, it continues just like the homologous series of alkanes. But watch out, the alkene homologous series are characterized by Ene endings. This means that after ethene, we have propene, butene, pentene, etc. For our purposes here, we will mostly focus on the homologous series of alkenes, which have a double bond between the first two carbon atoms. Because of this double bond, alkenes generally bind two less hydrogen atoms than their corresponding alkanes. Whew, math and chemistry, they can get pretty complex. But don't worry, it also means that to work out the molecular formula, you don't have to be counting each and every hydrogen atom anymore. It's much simpler to remember the general formula CnH2n by heart and insert the corresponding numbers. That means substitute the number of C atoms for N. That way, C atoms bind to two hydrogen atoms. Too much theory? In that case, it's best to take a quick look at the ethene examples. So, the Ene ending tells us that we are dealing with an alkene. That would be the first step done. Next, we'll determine the molecular formula without counting each and every hydrogen atom. To do this, we simply insert the number 2, which indicates the number of carbon atoms in the general formula CnH2n. Et voila! We have just determined that ethene has the molecular formula C2H4. So, do alkenes have other characteristics? Yep. Just like alkanes, alkenes can also form isomers. This means that the same molecular formula can give rise to different structural formulas. Hey, what? Don't worry, also easy. It simply means that butene, for example, which has the molecular formula C4H8, can occur in different structural forms. It has the same molecular formula, but can be structured in different ways. Now that's logical, isn't it? Alkenes can do something else still. They are, for example, poorly or not water-soluble at all. But to compensate, they are flammable. When their combustion is complete, the carbon-hydrogen bonds are rearranged to form carbon dioxide and water. The structure and properties of alkenes are crystal clear now, right? But what do they have in common with rotten bananas? Are you ready for the explanation? Let's go! Bananas are normally green when harvested and therefore not ripe. But they are treated with an alkene called ethene on their way to the supermarket. This artificially ripens bananas so that they hit the shelf nice and yellow. Alkenes can speed up the ripening process of some types of fruits and vegetables. Stupidly, apples also give off colorless and tasteless ethene gas. So if you pick apples with your bananas in your fruit basket, the bananas will get even riper and therefore go bad much quicker. There you have it, a useful tip. Keep your bananas away from apples. And that's all, folks. Let's just summarize all the important bits about alkenes. So, alkenes are unsaturated hydrocarbons with at least one double carbon-carbon bond. You can recognize alkenes by their Ene ending. And to determine their molecular formula, you have to remember the general formula of alkenes, CnH2n. Do you want to find out more about hydrocarbons? Then stick around to meet the alkyne family. Till then, ciao!